Hello everybody, we're going to be working on Unit 9 today. This is our last unit of the semester, which is kind of a milestone of accomplishment really. The chapter that we're going to be covering is chapter 14, so this is the last chapter in the book. So we have managed with the completion of this unit to go cover to cover in that textbook, which is pretty impressive when you think about it. I do want to remind you though that textbook, and I don't know if you guys have rented your books or purchased them, but it's always good to have a hard copy, in my opinion, or an electronic copy that you have in your archives as a reference. But certainly with HTML, if you opt not to, there's plenty of resources out there. I am going to explain a couple of things inside this unit for the people watching the video, so that you are aware of what's coming up. First of all, you'll see that there's a notice for the final exam here. When your exam is due is relevant to how you're taking the class. So for all the people here in the face-to-face class this fall semester of 2019, they have a solid week to work on the final exam. That's not always the case, so always be mindful of that. I also have the reminder there to use the Get Out of Homework Free coupon. If you need it, it's kind of a little bit of a safety net to maybe opt out of one assignment, or if you just don't have the time to get to it, snarf up on those 2 points. Just follow the instructions there and in the syllabus to use that. The interesting thing is, assignment-wise in this unit, we are going to be talking about the JavaScript chapter, but if you scroll down to the assignments, there's a couple of assignments here that for those that are in the face-to-face unit, and I know I just said this 2 minutes ago to you guys before I hit record, that I do ask that you wait until we're in the last day of class next week before you submit either one of these. For those that are taking this online or an accelerated format as with the full stack certificate, you can go ahead and proceed with these because you have much less time to work with. But those in a face-to-face session in particular, I do kindly ask that you wait until the last week before you submit that. The final project is detailed here, so we really have no homework that's directly related to the JavaScript chapter that's required. And in the past, they used to offer up an extra credit version of it, and I'm not really too worried about that. Right now, it's more the concept that's important. So aside from preparing for the final and finishing up your project, you really have no new homework that's being thrown at you. So I hope you guys are going to breathe a sigh of relief. The other thing that I'll tell you, are you cheering or are you asking a question? Okay, the question.
So, I don't know, so Java, that's different from JavaScript, right? Or are they the same?
No, they are very different. In fact, that's the first part of the lecture. JavaScript is not Java, folks.
Completely different.
Yeah, they're two separate languages. However, they do share a lot of techniques syntactically, meaning they both are what we call curly brace languages and semicolon languages. And some of the language that you use will work in both languages, but they're not the same language at all. And we'll talk about that in just a little bit. Okay. But there's no homework directly related to the JavaScript chapter. It's more informational than anything else. All right, now I do have the PowerPoint up here in the background, so let's go ahead and start digging into the material. There are a fair number of slides here. I'm going to cover them kind of subjectively, so I might kind of skim over some of them and then cover some of them more in depth. All right, so let's take a look at the objectives for the chapter. So some of the things we're going to learn about are what JavaScript even is. JavaScript works with this thing called the document object model. I'm going to teach you guys how to do some really simple JavaScript operations, and we're just going to do it as an exercise here in class, just so you kind of get your feet wet with it. In the old days of this course, we used to do like 2 whole units on JavaScript because the JavaScript course that we had was only a 2-credit course at the time, and then we had a separate jQuery class, and then we decided to make a 3-credit JavaScript course and remove most of the JavaScript from this course so that we could expand the HTML knowledge, which we felt was more important. Just so you know. So really, when we learn JavaScript, we are learning a programming language, frankly. And so you're going to learn about some basics of programming languages on a very superficial level, okay? And then we're going to learn about some of the libraries like jQuery. Then we're also going to learn how you work with some of those jQuery tools, also, once again, on a fairly superficial level. Let's move on to the first real slide here. And this first slide talks about what is JavaScript. And this is really kind of an interesting thing. Now, a quick poll. How many of you are taking Python? I know the people that are in my class, right? And how many of you are taking Java? All right. So
Java too, if that's what you mean.
yes, that's exactly what I mean. And the reason I ask that question is this. If you're learning a traditional programming language, like Java, and I call Java a traditional programming language, I don't necessarily call Python a traditional one, and I'm going to explain why. Java is what we call a compiled language. You write code, you compile the code when you debug it, and then if it passes the debug phase, it turns into what we call bytecode or machine code, binary information the machine can read, and it runs the program. Python is what we call an interpreted language. It does not actually compile. It just runs. And JavaScript is an interpreted language also. It does not compile. It does not turn into machine code. The code is just executed in your browser. Beyond that, you've also learned in Java that Java is an object-oriented programming language. So you learn about objects, classes, inheritance, polymorphism, constructors, overloading them. So maybe you've heard these terms, maybe you haven't. And then in Python, even though it's an interpreted language, it also is an object-oriented language. It also has objects, classes, inheritance, and all those things. Works a little different than Java. Now, when we look at JavaScript, right off the bat, the first point is it's an object-based scripting language. It is not technically object-oriented in the same way that Java or Python is. But what a lot of people do in JavaScript is they simulate object-oriented programming because everything in JavaScript is based upon objects. And the reason that is because it's an interpreted language that runs in the browser, and the browser treats every aspect of the JavaScript language as an object. And that's kind of a deep subject, so if you're really new to programming, that might mean absolutely nothing to you. But if you have some programming experience, that might actually be eye-opening for you. So everything that you do in Java is actually based upon objects. And yes, you can simulate object-oriented programming with JavaScript, and it's getting much more powerful these days as they keep expanding it. I'm going to argue that as a web person, JavaScript is probably the single most important language you're going to learn. Perhaps even more important than the HTML itself. And the reason is, HTML on its own, even with the power of CSS, and we saw what CSS can do, can't really do a lot of stuff in the browser without JavaScript. JavaScript is what allows us to do math, to perform logic, to do things on the back end that the user is completely unaware of that seems magic. And it's really kind of, I always think of it as kind of like the glue that holds the internet together. It's so powerful. JavaScript, because it is not a compiled language, it's an interpreted language, it is capable of being delivered in plain text to your browser and executing inside the browser directly. If you use other programming languages, like next semester you guys will learn how to use Java and PHP to do back-end programming on server side, and we'll learn about this concept real soon, that would run on the server and then push HTML to your browser. JavaScript can operate directly in the browser. That's what makes it really powerful. So let's think about going back to this thing now, object-based scripting language, and it says it works with the objects associated with a web page document. So it can work with the window. It
Work
can.
with that scrolling slideshow too, like I have to work with that.
Yes, yeah, that's true. It can work with the actual document, so the whole page, or it can work with any portion of the page. Anything that sits inside of a tag can be manipulated directly with JavaScript. But it's not just the stuff on the, in the page, it's the page itself and also the whole browser window. So all of those things, JavaScript treats them all as objects that it can manipulate. And that's one of the secrets to the power of JavaScript, is that very significant thing. Now, JavaScript is not new. Okay, so it says here it was originally developed by Netscape. And if you remember, Netscape is the company that put out what we call the first commercial browser back in the 90s. And Netscape, of course, was based on what most people think of as the original browser, which is Mosaic. Same people that developed Mosaic. A couple of Wisconsin kids down in University of Illinois. So I always like to point out that it's a Wisconsin invention, the web browser. They went on to form a commercial company called Netscape, and then very quickly they discovered that in order for a web browser to really be an application delivery platform, it needed to be able to do more than just show text on the screen with a couple of links. It needed to be able to do stuff. Because even back then they had this really clear vision that the web browser was destined to become what we call the universal client. So when I was learning this stuff, so when Netscape came out, I'll just kind of give you guys some perspective here. When Netscape first came out, I was still, working on my college degrees, plural, back then. And I remember going to a presentation on it, and the goal back then, the mindset was that the internet's going to be the delivery platform for all applications in the future, and the web browser is the tool that allow you to run all applications in the future. So even almost 30 years ago, they were seeing the power of what the web browser could do. But in order for it to get to the point where it could do the things like, for example, think about this. When you guys log into Microsoft Office online, if you use it online, you're running Microsoft Word in your browser. Or if you're doing email or Google Docs or whatever you're doing it in the browser. You're not downloading a piece of software, installing it, configuring it, hope it works, then connect to the internet and all that stuff. We're in like the always-on internet era now, right? Like you start your machine, you're on the internet, you bring up your browser and you do your stuff. In fact, most people that use machines these days really don't use a lot of software beyond their browser. Even a lot of the applications inside of our operating systems now, particularly on these little mobile devices, the one I'm holding up here, are really just fancy web applications. They're really just browser windows that look like an app, but they're really just a browser window. That's kind of revelatory. So we really have gotten to the point where we've reached the universal client mindset. So the people at Netscape were like, all right, you know what? We need to write some sort of a language that will operate inside the browser. They ran into a problem right away because most programming languages at that point were compiled languages. So in order to run something inside the browser, they had to come up with what they call an interpreted language, meaning you have a command, the browser interprets it and runs the command. It does not turn it into machine code or bits and bytes that only the operating system can read. The browser can read it. And all we need is plain text to do that. So built into all of our browsers, all of our modern browsers have a JavaScript engine built into them to execute the JavaScript that they download from the web server. So this is another interesting little tidbit. Did you know that all of our operating systems also have JavaScript engines? So Microsoft Windows has one, the Linux operating system has one, and the Mac OS has one. So you can actually build full-blown applications that run on JavaScript that run inside your operating system. That's kind of not a brand new invention, but it's been around for a while, but a lot of people are unaware of that. So the original scripting language they came up with is called LiveScript. And for better or for worse, it was what it was, and people started coding for it. And in the early 90s, there was really not a lot of development with that because a lot of people didn't understand really what it could do. But then Netscape collaborated with Sun Microsystems, and it just kind of give you a trail here. Sun Microsystems was a company that built computers and mainframes and had their own Linux operating system, and also developed the Java programming language, which you guys will be learning about in your other courses. Sun, of course, got bought out by Oracle eventually, but back then, Netscape and Sun collaborated, and they ended up renaming LiveScript to call it JavaScript, following in the footsteps of Java. Okay? So I'm not sure what the rationale was there. I think they were just riding the coattails of Java, because at that time Java was newish, and a lot of people were jumping on board, because it was one of the first languages that allowed you to code the same code on every operating system. So prior to Java, if I wanted to write a program that would run on a Mac, I'd have to code on a Mac. So if I wrote a program on a PC, I couldn't just pick it up and take it to a Mac and run it with the same code. I'd have to go over to the Mac and rewrite the whole darn thing. But Java came out, and what Java had as a power is the ability to run on any operating system, provided you have the runtime engine installed. So it would create a virtualization layer above your operating system, and Java would run on top of it. JavaScript, it was just a naming thing, but it is really important to note, and this is like a catchphrase, JavaScript is not Java, and then when you pick up your Java book, it'll say Java is not JavaScript. They do share a lot of similarities in how the language looks when you're coding it. So chances are, if you learn JavaScript and then learn Java, you'll be fine. Or if you learn Java first and then go to JavaScript, you'll be, oh, okay, I get it. So a lot of similarities, a lot of syntax similarities, and I always like to say they're both curly brace languages with semicolons, and and a lot of the terminology is similar. All right. So what do we use JavaScript for? We use JavaScript to basically do stuff in the browser that we can't do without. Okay. So we can put pop-ups up there, message boxes. We can drive our navigation and make it dynamic. We can edit and validate form information. We've talked a little bit about that. Create new windows, specified size and screen positions. We can do image rollovers. You can also do that with CSS now. We can provide status messages. We can probe the current date off the system. And I think most importantly, we can do math. And if you guys are learning how to program, you realize that most of what we do in programming is math related, or logic related at the very least, which is really math also. So how do you create JavaScript? How do you code it? Well, you can add it directly to your HTML. You can actually put in what we call script tags, and then put your JavaScript code inside the script tags. So really what you're doing is you're injecting a programming language into your HTML. So it can be part of your HTML. Or, like your CSS, you can put it in an external file and link it to the page. And that's really considered a better approach. However, both approaches are valid and used. A lot of times when you look at web page output and you see script tags, sometimes those are dynamically added to a page by like a content management system or a back-end language. Sometimes they're manually placed. All right, let's take a look really quick at a really basic JavaScript little routine here. And you know what? What I'm going to do in just a moment is I'm going to fire up my editor, and we'll create some code exactly like this. So the first thing that you're going to see is that we use a script tag. The script tag does have an opening and a closing, and then anything that is put inside the script tags is not written in HTML anymore, folks. It's written in JavaScript with its own syntax. It could be one statement like what we see here, or it could be multiple statements. Could be many lines of code. The one thing that I find interesting is when we were using older versions of HTML, when we used XHTML and HTML 4.0 most notably, if we wanted to insert JavaScript, we also had to include what type of script it was. We would have to say type equals text/JavaScript. And there are still some situations, albeit rare, where you still have to include that. The reality is that type statement in modern coding can be eliminated because whenever you use the script tag, JavaScript is assumed because it is the default for the browser. All right, let's do this. Let's go ahead and bring up our editors. I'm going to pause the video for a second while I launch my tools and get ready to work. You guys should do the same. All right, now I have my tool up and running, and normally I would say that if you are working on homework or project building or whatever, you should first always make a version of your work before you proceed. So go into your folders, make a copy of your folder, and work on the new version, leave the old version alone, and that way you can always backtrack if you mess things up. All right, so I have the Mr. Robot thing that I've been working on in all these videos, and I'm on my code example page. And this is where I'm going to do the work. I think this is a good spot for it. So I'm going to just look at the example that they have here, and I want you to look at the code. Very, very basic. They're script tags, and then we're doing an alert box with a string inside of it. That's what we call it when it's inside double quotes. So I'm going to create something just like that right here inside my document. So I'm actually going to start by going into the body section of the code. So the visible code on the page. And right here at the top, I'm just going to type script. It's going to get closed right away, so I'm closing it to make sure. Inside here, I'm going to tab in one tab stop, and I'm going to type alert, put in a set of parentheses, set of double quotes, and I'm going to type some sort of snarky message like something like that. That's not proper grammar even, right? It should be, what are you looking at? All right. Now notice that the book demonstrates that inside the script tag, you might say type equals, and I want you to see that there's different options here. And notice how it's changed from what the book is recommending. The book types this, text JavaScript. But you notice that Dreamweaver is saying application JavaScript. And you know what the truth is? Either one of those is relatively equivalent. And frankly, not needed because JavaScript is the default language. But if you were using some other script, and here's the thing, some other back-end languages that you might work with might require that you put the type in order for that language to work with it. So that will be highly subjective, and if you're working at that level, you'll know. But for right now, my recommendation is just skip it and just type the script tag in. All right. I'm going to go ahead and save this, folks. Now, what's going to happen here is as the body section of this page loads, it's going to hit this script, and it's going to put up what we call an alert box with this message. So I'm going to go ahead and load this page into the browser. So here we go. Of course, it went down to screen number 2, but here's the result. So you see, my page loaded in the background, but I got a pop-up. and it says, what you looking at? Snarky, right? And my only choice is okay. That's your most primitive JavaScript example, but we just executed some programming code on a web page. And for as simplistic as this is, we've just added JavaScript to the page. Yeah. And this is kind of like, you know, the typical, like, anytime you learn a programming language, it's like your hello world thing, you know, just get something on the screen. And that's hello world for JavaScript, and that's how we do it. Now, I loaded that into the body section, all right? And you know what? The beauty of JavaScript is you can do that. You can just drop JavaScript code right into your HTML, right in the middle of it. But when you start to do this, there's going to be reasons why you put it in certain places. So you're going to see a combination of techniques from people. Some people will put their JavaScripts in the HTML. Some people will take this script and they'll put it in the head section of the document. And actually what's more common in the head section is that you have a link to your JavaScript as opposed to actually putting the code in. So we'll talk about that in a second. But for right now, I moved it out of the body and I moved it into the head. Will that mean it won't operate? Well, let's go back to the page and do a refresh. It's still doing it. Well, what's the difference?
You don't have the web page show up.
Bingo. This loads before the visible section of the page loads. See the difference? So I don't get to see the page until I click OK. Interesting. Very interesting. Now, either way, I couldn't get to the page and do anything on the page until I clear that box. Okay. Another technique that people will use is they'll take that script, and sometimes you'll see scripts loaded at the very, very bottom of the page. In fact, either just inside the closing body tag or even after the HTML tag. So I'm going to throw it in down here and save it. Let's go back and refresh again. Let's see the effect. Interesting. I'm going to tell you real frankly, not what I expected. So I'm wondering if I'm even getting a fresh version of the page. So I'm going to do a Control F5 refresh. It's doing the same thing. Let's do go into inspect mode, and let's do a hard reload this way. Still the same. Let's do a empty cache and hard reload. Still the same. So I'm wondering if our first script pop-up was anomalous, honestly. Very interesting, not very predictable. But let me give you the understanding as to why people might put scripts in different places. Sometimes you need to put the scripts at the bottom so you can allow the page content to load first before you manipulate it with JavaScript. So you might have code on the page and then write JavaScript to tell it to disappear and not show until somebody clicks something or fills out a form or hovers their mouse or whatever the action happens to be. Where you place it will be relative to what you're doing, but I think for a script like this, I would either place it here at the top. Let's put it back at the top, and I'm really curious. I want to refresh it again, right? Let's refresh it. Okay, so see how I thought it was anomalous behavior? Yeah, I think it was being anomalous. So. And it could be because it was loading a cached version of the page in the background. Now that I think about it, that makes a lot more sense. All right, so where you place it really depends. In the HTML or up in the head section, either way is fine. All right. Part of what allows JavaScript to operate and do its magic is this document object model structure that we're looking at right now. And if you have the ability to kind of like zoom in on the bottom part of that slide and see some of the details there. I'm going to do a couple of clicks of zoom here, not too much. That's pretty good right there. And there's a hierarchy when we start looking at our browser, all right, in the way that JavaScript operates. So JavaScript sees our browser like this, in this top-down structure. So at the very top, we have the browser window. Now, that appears as a little block, which means it's an object to JavaScript. It means it can be manipulated, meaning I can look at the window, I can create windows, close windows, I can navigate through the history of windows, etc. The window itself will contain the document. Okay, so the document is our HTML page. The HTML page, of course, contains objects in the form of tags. So we have anchor tags and paragraph tags and whatever. They just give you a few just as an example. So then you have forms and images, and some of those items have sub-items that attach to them. So a form might have an input element or a submit button, and an image might have an attribute called the source, just for example. And what's interesting about JavaScript is JavaScript can go in and manipulate each one of those elements. So I can actually create the element, destroy the element, or click the element, or change the element, right? So if I have one image on a page, I can tell JavaScript to take that same image tag and change it to something else. Yeah, it gives you all sorts of ideas, right? Yeah, like a real programming language. All right. You also, from the window, you can go into the history. So I can be on a page, and I can write a JavaScript command that says go back 2 clicks in my history. Or go back 2 pages. You know, a lot of like nefarious websites, like you go to them, and then you try to hit the back button to get out, but you can't. It just puts you right back. That's JavaScript doing that.
So like when it says, would you like to restore the whole web page as Java?
No, it might be. It might be. You're talking about like when, let's say, you accidentally shut down your machine, you go back to your browser and it says,
No, like,
do you want to restore
like,
the pages?
When you like you were filling out something and you've like been off it for a while, then you go back to it and it says, would you like to restore information?
Oh, yeah. That's probably stored with JavaScript. Yeah, probably.
Yeah.
That's a good question. The other thing you can do is you can actually change the location. So what that means is I can use JavaScript, so I can write a JavaScript script that when I land on a page, it takes me somewhere else. Or if I click on a link or an object, it can take me to wherever it wants me to go. To a different website, a different page, you know, et cetera, et cetera. It also can actually probe the browser itself, and that's this navigator thing. And the term navigator is actually a remnant from Netscape, because they were the first ones to really work with the document object model. So navigator indicates the browser you're using. So JavaScript can actually probe the browser information and say, hey, what browser are you? Oh, you're Chrome or Firefox or whatever, and then feed that back. And it can pull back the name of the browser and which version it's using. It also pulls back the operating system that it's operating on. So now common usage for that, frankly, is sometimes you build pages and you know that somebody's either going to hit it with a mobile browser, or maybe they're going to be on a Mac, or maybe they're going to be on some old PC, so you can probe like the version and whatever and load different stuff for them if you know they're on a small screen or if they're in a different operating system. Or sometimes that information is just probed and analyzed. In other words, we use it to do analytics on websites. So like if you subscribe to Google Analytics, for example, and add their JavaScript code to all your pages, it will keep track of every visitor, every page, and keep a detailed listing of like, this user from this IP address came in and was using Chrome on a Mac and this version. And all of that stuff can be read directly because of JavaScript. So it's pretty interesting. Now, the thing about the DOM, and that's what we call it, the DOM, is that it is like a really critical piece of making JavaScript operate. Because if you're going to write a programming language that's going to be able to manipulate the browser and its content, you have to be able to access those items. So that was kind of like the first big step, was to take all the pieces of a web page and turn them into objects inside the engine of the browser. And then JavaScript, which runs inside the browser, can then manipulate those elements. So this is pretty important stuff, right? All right, what's an object? It's a thing or an entity. Okay, the browser window, the button, the document, a paragraph, an H1, and any of those things can be objects. All right. One of the things we can do with JavaScript is we can actually change or look at certain properties. So you can look at like the background color of a document. They're giving you some syntax. I'm not really worried too much about the syntax. You can also look at when the document was last modified. So I can look at the timestamp on the file that we're pulling in. Yup. Or the source file of an image object. I can actually change an image to a different image without changing the tag. It does it dynamically. Pretty interesting. We also have the capability to run what we call methods or functions. And often we'll have stuff like this. So you'll see like a document.write. And what that JavaScript command does is it writes stuff to the browser. So for example, you might have a little thing that says, you know, if the person logs in, then we can write to the browser, hello, Joe, thank you for logging in. And what kind of stuff would you write? Well, it could be text, it could be HTML, it could be whatever goes on a web page. You could write with that command. You could also have something respond to like the click of a submit button. So if somebody clicks submit, what's the action you perform, right? I know that when we did our first form, we've talked about this a little bit, but all we were having it do was go to another page. It's kind of simulating that we did something. But you can actually write JavaScript where it actually does something, you know, calculates the math, you know, takes you to a different website, et cetera, et cetera, et cetera. Maybe validates the contents of your form, right? So JavaScript often operates either automatically, like the script that we just put in. We didn't like have a button that you click to make the pop-up come up. We just loaded it. But more often than not, JavaScript is capable, like other GUI programming languages, of reacting to events on the screen. So whether you click on something, or hover over it, or click and drag, or go from page to page, it can respond to all those things. And you can write code that responds to it. Real common piece of code is, once the page loads, do this. Or, once you click that button, do this. That's kind of the thinking. But you can respond to many of these events, and this is just a small smattering of all the events that are possible. These are some common event handlers. So on the left is what you think of calling it, and on the right is what JavaScript calls it. So if you want to write a JavaScript command relative to an object, you could say paragraph on click explode, or whatever, you know, whatever explode does. All right. So some fun stuff that you can do is you can write little scripts like the one at the bottom. So the one at the bottom has a link, right? An href, an anchor tag with an href that takes you to a certain page. And notice what it says there. On mouse over, that's a JavaScript event. It can be added directly to a tag, and then you can trigger an alert box just by hovering over something. Not clicking, hovering. How annoying would that be? That means you're never clicking on that link, right? So this is one I'm not demonstrating, but that's just an example. So when it comes to actually dealing with JavaScript debugging, so like if you guys are learning Java and you're learning Python you know that you're working inside of usually at what we call an IDE, and when you type the code wrong and you hit the button to run, down at the console at the bottom, a message will pop up telling you what your error is and kind of how to fix it, sort of, right? You get to learn how to work with it. Here's what happens with JavaScript. With JavaScript, if we go to our browser and we do the right-click inspect, and we go into the inspect panel, right here as part of the panel, and depending on where your panel appears, so for many people, the panel usually appears at the bottom. One of the tabs in the inspect tool is what we call the JavaScript console. So if I come into the JavaScript console and type that alert command and say, like this, same command, right? I just typed it at a prompt and press enter. So I can go into the console and directly type commands in, and I can do really goofy things with it, right? So you saw I just created an alert box. I can also do math. Pretty wild. You know what? This is the power of an interpreted language. This shows you that your browser's got a JavaScript engine built into it and a console where you can actually interact, right? You can write code right in the console. More importantly, if your code's got a problem, the error message, the debugger, is in the browser. All right, let's test that theory. All right, so I got a script tag here. And you know what? Let's say I misspelled alert. Allure, whatever that is, right? And I'm saving it. I'm going to go back to the browser, and I'm leaving the console open now. And I'm going to do a refresh. Notice it popped up a little error message, right? So this is the JavaScript console. It says, uncaught reference error, allure is not defined, blah, 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 blah. It says, where at codeexamples.html:13, which means line 13, and there it is on line 13, it knows it's wrong. Okay? And so often when you're building applications with JavaScript, it will allow you to see what your problems with your code are right here. So that's one of the ways that you debug JavaScript applications, is directly in the browser with the console tool. Now, in terms of these tools that you see in the inspect panel, now all the major browsers have this. So Chrome, Firefox, and Edge, and Safari all have these tools. In the past, it wasn't that way. Firefox was by far the first one to have it, and when they first added this, they called the tool Firebug, and it was an extra tool you had to add to the browser, and it basically gave you like most of these inspect tools, but most notably the console for debugging JavaScript. So you can imagine like writing computer code and not having a debugger available. So they came up with this approach, and this is probably the go-to #1 tool for JavaScript developers in terms of solving their problems. All right. So they gave you techniques for debugging, and I'm not really getting into the details of that because we're not really learning the language in depth, but it shows you here basically the same thing that I did. Now they're suggesting that you use Firefox here because at the time that the author probably wrote this, it might have been that Firefox was the only one that actively supported it. So interesting, I think. All right. Let's talk about some of the stuff that JavaScript does. I'm not going to demonstrate most of this, but those of you that are learning other languages will, tap into this pretty quickly. In JavaScript, if you want to declare a variable, all you have to say is var, V-A-R, and the name of the variable. That's all it takes to basically create the variable. Notice what's missing from it, though. You do not have to declare data type in JavaScript. JavaScript doesn't care what data type you put in this variable because it's an interpreted language. So when I set up a variable, I can put a string into it, and then the next step, put a number in it. No problem. It'll do it just fine. Not only that, JavaScript is capable in their variables of storing complex objects. So entire applications can be stored in a variable, or entire functions or whatever. So you see a lot of different techniques. So they give an example here. They set the variable username. They store the string Karen into the username, and then they output username to the screen, so Karen would appear on the screen. And in fact, if this is plain text, and all of these are images, and it really kind of frustrates me, I'd copy paste it into the console, and you could do that right in the console and see it work. Not a big deal. Right. So, very simple. You can do another thing. You can do a prompt message. And what this does is it gives you a different kind of output. So I don't know if this is, once again, so they're setting up a variable called my name, and then they're doing a prompt. I'm just saying type something. I'm going to save that, go back to the page, and do a refresh. And notice the prompt gives you somewhere to type, and an OK and cancel button, so I can say, hey. Now, it didn't do anything because I didn't program it to do anything, but it did get stored in a variable called my name. Interesting. So just a very primitive example, but that's one way that you can capture information from the user. You can also do math with JavaScript, and it uses the same operators that are common in most programming languages. The equal sign is not an equal sign in JavaScript, like in most languages. It's an assignment statement, which takes the value on the right and assigns it to the variable on the left. So that first statement that says quantity equals 10 means that I'm storing 10 in a variable called quantity. The other thing that's really kind of interesting is, I don't know if you guys caught this, but here I declared a variable, and I didn't put the keyword var in front of it. And JavaScript lets you do that too. It doesn't care. Just go ahead. That's kind of the neat thing about JavaScript and kind of the weird thing about it. The math operators are the same as, the 4 core ones are the same as any language. So addition, subtraction, multiplication is an asterisk, and a / is division. Also has some of these comparison operators. Equal is where you're checking to see if things are equivalent as opposed to assigning a value. Meaning, is the value stored in quantity equivalent to the number 10? Not assigning 10 to the variable. See the difference? And then the other ones, less than, greater than, etc., are similar to other languages as well. You can also declare not equals with an exclamation point. JavaScript also allows for conditional statements. So if you guys know your Java code, this looks very, very, very much like regular Java. The if statements are basically identical. So you type the keyword if, you put in a condition that you're checking for true or false, and then inside a set of curly braces, commands to execute if it's true, and then you can throw in an else, and then commands to execute if it is false. So pretty standard decision-making steps, or selection steps, if you want to call them that. We can also declare functions in JavaScript. So you just use the keyword function, give it a name, put a set of parentheses after it, and then you can have a set of commands that are predetermined, and then to execute those commands, you just call the function by name, and it runs. Pretty simple. So for example, if we were to create a function called showAlert, we put their alert statement inside of it, then anywhere in our script, we just call this, and it will execute whatever's inside there. Not too difficult. One very popular usage for JavaScript in the past was form validation. In fact, I think back to like one of the first few times I taught JavaScript, and this is, I'm dating myself, quite a while ago. And before HTML5, one of the only ways to make sure that what people were typing into a form was correct was with JavaScript. I'd have to write JavaScript code that would say, if the input box for first name is empty, put an alert on the screen saying, hey, you forgot to put in your name. What's wrong with you? Put in your name and click submit, right? And now we've learned that with HTML5, with all the new things that were added to it, we can do a lot of that with just HTML. We don't even need to use JavaScript anymore. However, careful programmers always use multiple layers of validation. They use the HTML validation, they throw in JavaScript on top of it, and then they put more validation on the server, often because that data is going into a database, and if the data is not clean going into the database will break and reject it. So you got to catch that stuff before it gets there. Because JavaScript is really flexible. A lot of back-end programming languages are not. They're not flexible at all. Right, here's an example of how you might validate a form field. Don't worry about it, you guys can do that in your next class. But you can also run into situations where some people, because they're paranoid, disable JavaScript in the browser because they think that their whole system can be hijacked with JavaScript. And the truth is, that's not possible. JavaScript can only manipulate the browser. It cannot manipulate your file system. It cannot manipulate your operating system, just the browser. So that's, I think, pretty important to note. A really popular thing, once you learn how to work with JavaScript, is you start learning that JavaScript has a lot of pre-created libraries that do these marvelous, awesomely powerful things with very, very little coding. And so jQuery is by far the most popular JavaScript library. It was developed, I'm going to say roughly, I think 15 years ago. I think Google was a big proponent of it. I don't know if they adopted it from somebody else, probably bought them out. Somebody was developing it and they probably bought them out. But they became really big proponents of jQuery because it allowed them to really accelerate their development in the browser. So JavaScript is powerful on its own, but when you have a library that you sit on top of it that allows you to do things like animate an object with one keyword, like move or hide or anything like that, it's crazy what you can do with jQuery by just typing a couple of keywords. It's pretty amazing, actually. And it's all because there's this library. But in order to use the library, you have to either download and drop the whole library into your file structure and then link to it, or you link to an external repository, which is always my favorite way to do it. So I would, for example, if I was using jQuery, I might link to Google's jQuery library because the chances are that it's already loaded in your browser cache, ready to go, and will operate amazingly. But it allows you to do a lot of different things. So you can manipulate CSS. You can do that with JavaScript too, but it's easier with jQuery. And the secret of jQuery is this, that it operates with CSS selectors. So the same way that you would select an object inside of CSS, you would select it with your jQuery, and then you just chain your actions after it. So you can have it, as it says here, manipulate CSS, react to events such as mouse movements, animate things, and much, much more. Yes, absolutely much, much more. It's really easy to add. You can go and download it, or like I mentioned, you can just drop in a script tag like that one that points to Google's repository, and then it's pulled in. You don't even have to add it to your project. It just links to the outside world, and every time you run a jQuery command, it pops up on the screen. One of the keys to getting jQuery to work is to use the right syntax. So it's really common when you write jQuery to have this somewhere in your JavaScript code, which is what we call the document ready function. And what that basically does is it says, when the document's loaded, we're all ready to go, execute this code. Okay? And then all jQuery statements are always preceded by a $sign. So if you're ever looking at JavaScript and you see a $sign at the beginning of a statement, it's just saying this is jQuery. Simple as that. Right? If you wanted to do an alert with jQuery, and this is not, I don't think this is a good example, because what it's doing is it's running jQuery document ready function, and on the inside it's doing regular JavaScript. But it does tell you that you can intermingle regular JavaScript and jQuery on the fly. They don't care. As long as you have that jQuery library there, it will do the work. What's more interesting though, like I said, the jQuery selector. So if you look at, like if you want to perform an action on an object, you look at the selector. So the first part after the $sign is which thing you're selecting on the page. And if you look at the syntax there, you'll notice that the syntax is identical to like picking a class or an ID or a tag directly. So the same syntax you use in your CSS document to choose an item, you use in your jQuery. Absolutely the same. jQuery, the reason it's so cool is it's basically a really fancy API is what we call it. And an API is what we call Application Programming Interface. Those of you in my Python class or in my Java class will learn that one thing that an API is basically it provides what we call a public interface for the programmer. So the programmer does not need to know what any of these functions do or the code that makes it do what it does. You don't have to know it. But if I want to like fade toggle something, so that means click on something and have it fade out, and then click and have it fade back in, I just have to use fade toggle. I don't have to write the code that does that. So that's what an API does for you. And that basically, jQuery is a JavaScript API or library. And there's many, many out there. jQuery is not the only one. There's probably hundreds of JavaScript libraries. Some of them are custom, some of them are public. And as you learn more and more about web programming, you're going to learn that that's really kind of the way to work. So you learn your basic JavaScript, and then you're just pulling in different APIs and calling their functions. And that's how people are able to rapidly develop really cool looking applications without barely any coding. But you have to understand the basics first. jQuery is by far the most popular one. So they give examples here. In this example, they set up the script tags. Document ready function means it loads up our JavaScript and jQuery. And then we have a little thing here that says $A. The A is selecting an anchor tag or a link, right? That's what an A tag is. And then when you click, we trigger this function. And it says, when we trigger the function with a click, we're selecting the even numbered list item elements. That's the CSS terminology for it. And then we're changing the CSS, which one, the color, to this color. So that's jQuery that allows us to choose a specific selector, change the color or the CSS of the item dynamically on the fly relative to a mouse click. And I don't expect you to understand this all right away, but this is a preview. When you guys go into your JavaScript class next semester, this is the kind of stuff you're going to learn. And the magic, of jQuery, so for example, here's one where if you click the paragraph or click the More button, then it shows you more stuff. So remember when I showed you the Gateway web page earlier and we were looking at the program courses and you click on the box and then the thing pops down? That's all done with jQuery, folks. Really simple, actually. It's so simple it's kind of scary. That's the beauty of this tool. Real popular thing that people have done with jQuery is they create things like image galleries. They give you some sample code here if you're really interested. If you were to do the Chapter 14 case study, this is one of the exercises where they have little thumbnails, and then you click on the image and it pops up a bigger one, and they show you exactly how to do it. All right. jQuery, you know, it is a plugin, so you can actually go to these different places and download different tools. jQuery is not just one library. It actually has many, many, many libraries. So they have ones for user interface elements, for mobile devices, for doing animations, etc. And then couple that with the fact that jQuery is not the only name in the game. And so when you become an experienced web developer, and probably by the time you guys are pros, I'm sure jQuery and JavaScript will still be around, but there'll probably be all these new libraries coming out. And you know what? One of your jobs as web developers is to try those out and find new ones and cool ones, because some people do really amazing development work, and the fact that they share it with the world is really cool. And you can just bring their whole library in, learn their basic commands, and then do some crazy powerful things with hardly any code. And that's really what it's all about. But once again, the whole point of JavaScript and jQuery, folks, is the fact that we can start taking our browser pages, our static web pages, and turning them into something dynamic that interacts with the user like a real application. So it takes us out of the static web page world into the dynamic web page world. Dynamic in terms of the fact that it runs in the browser. Now, this is not server-side programming. I know we've talked about that a little bit. JavaScript and jQuery are what we call client-side programming. It executes on the user's system in their browser. Not to complicate things, but JavaScript has become so popular now that we also have back-end server technologies that also execute JavaScript, with the most popular one by far being a technology we call Node.js. And when you guys get to, I think it's semester 3, where you go to the Web Programming 2 class, you learn about Node.js and then a bunch of other frameworks, the Web API, the local database stuff, all, React and Angular and all those things. So JavaScript is, like I said, probably, I would argue, the most important of the languages you're going to learn in the web program, because it's used by so many different things. It's really powerful, and now that it's changed from not only being a client-side language, but also becoming a server-side language, it's really huge in the full-stack development world. In fact, when we say full-stack developer, we really think very much of the fact that the back-end programming is done with JavaScript. All the frameworks we're using are JavaScript-based. The libraries that we import are JavaScript, and all the actions that happen in the browser are JavaScript. So we're really using JavaScript now to develop entire applications. To take it a step further, because our operating systems also have runtime engines for JavaScript, we have full-blown applications. And I've been using Dreamweaver in this course to do my work. Dreamweaver is completely coded in JavaScript. And when I first discovered that, it blew my mind. That, wow, you actually can write a whole application with JavaScript? I didn't think that was possible. But there it is, folks. All right, this chapter ends here. And that's it.